So today I'll be talking to you about the InnoSwitch3-TN. The InnoSwitch3-TN is based on our InnoSwitch, which has an internal high voltage primary MOSFET, which has a primary controller, which is tied through our FluxLink to a secondary controller. And we've done a lot of special things on a secondary controller in order to minimize the external parts count. The primary MOSFET is tied to a transformer, primary. There's a secondary winding. This InnoSwitch3-TN also supports driving an external SR MOSFET, synchronous rectifier MOSFET, in order to improve the efficiency. And we've also integrated the current sense for output CC, or output current control. We've integrated the voltage sense resistors, so there's no external current voltage sense resistors in order to regulate the output voltage, and thereby really reducing the number of components you require externally for a complete flyback solution. So our FluxLink, which is internal to the package, bridges the isolation barrier between primary and secondary, and it is a magneto-inductive coupling inside, which is safety rated, which meets all the worldwide safety regulatory requirements, and is 100% high-pot tested at our factory for every device. So it allows us to have a secondary controller master, which controls on a cycle-by-cycle basis the switching of the synchronous rectifier MOSFET, as well as a primary side high-voltage MOSFET. So you'll notice there's no external winding or supply for the primary controller. All of Power Integrations products are self-powered. The way we do that is we have a high-voltage current source tied to the drain of the high-voltage primary MOSFET, which charges up an external bypass pin capacitor on a pin we call the bypass pin. And so this reservoir capacitor contains all the energy to supply the primary controller. Similarly, on the secondary side, the forward pin during the primary cycle conduction time is also used in order to charge up an external bypass pin capacitor on a secondary bypass pin. Now is all the energy is required in order to operate the secondary controller. So how do we do current sensing on an InnoSwitch3-TN? You notice on the primary side there's no external current sense resistor, and that's because we use a SenseFET in order to measure on a cycle-by-cycle basis the switch current in order to control the amount of current that's going through the device at every instant. And similarly, on the secondary side, we've also integrated the current sense resistor so that we can enable a constant current regulation output. So this schematic is for a single output 5 volt with a constant current, ideally suited for a 5 volt 2 amp or higher, depending on the size of the device you choose. But most appliances require dual output. And how do we achieve this with InnoSwitch3-TN? Very simple. With a simple AC stack winding, with an external diode, depending on the turns ratio you choose. Now we have a dual output, plus 5 volt, and depending on the turns ratio, a plus 12 volt output. It really is that simple. The turns ratio sets the output voltage for the second output, and its cross regulation is excellent by the mere fact that we have a synchronous rectification MOSFET here, which reduces the loss and drop for the 5 volt, enabling better cross regulation for a dual output supply of this nature. The way I've drawn it here, it looks like an isolated supply, but there's no reason why the return couldn't be tied directly to the primary return, and now you have a very simple non-isolated supply. We term the InnoSwitch3-TN internally as an origami of power supply, because you can do the single output, you can do the dual output, you can also do negative outputs by simply changing the connection point of this for an unisolated supply to this point. And so now this is minus 5 volt, and this becomes your return. So it's extremely flexible. What we've seen in appliance markets is a requirement for very high standby efficiency and high light load efficiency. And the way we achieve that is with our multi-mode engine inside the InnoSwitch3-TN, which slides in a continuous manner the peak switch current and frequency as a function of load in order to achieve very high conversion efficiency across the entire operating range. In fact, we were able to achieve greater than 80% efficiency for loads greater than 25% for the entire range. We actually also achieve zero no load with this product. So when all the outputs are disconnected, we measure less than 5 milliwatts, which is zero no load. With the InnoSwitch 3, we use an INSOP package, which is very space efficient, and we use PCB cooling in order to heat sink the device. For the InnoSwitch3-TN, we actually developed a new package, which is even smaller, called the MinSOP. To learn more about the InnoSwitch3-TN and our other products, visit us on the web at power.com.